Just gonna give it another minute while people are joining in.
Could someone post a link to the doc, the Google Doc, in the chat? I don't have
Sure,
the link
no
in front of
problem.
me. Thanks.
Yeah, I'll do that right now.
It's no Slack too.
See if that works for you, Don.
Oh, thanks.
Yeah, no problem. I think we have a quorum. We can get started. Great. So we have a bunch of agenda topics in there. Hi, I'm Cynthia Marina. I'm normally on the call, but I don't run the call. So I just heads up is that Alan's busy today, couldn't make it. So he asked if I could help out and just run the call. So if I'm doing something wrong or incorrect, just let me know. I was gonna go through the action items and have people chime in. And the first three topics we have on there, I'm actually gonna have Paul talk about the work that he's doing on the fast dedup pacing changes and the other two topics. And then we can talk on the rest of them and go through the PRs. But if there is something else that's higher priority, just let me know and we can move things around. All right. And right in the chat there, I just posted the link so you can see all the agenda topics in there. All right, let's start with Paul and to talk about fast dedup pacing changes that you're working on, Paul.
Yeah, hi everyone. So the changes that I'm working on right now are related to, so the dedup log is a mechanism that we have in ZFS to help sort of aggregate writes across the dedup table. So that way, when you're doing updates to the dedup table, you're not like updating because it's stored as a hash table on disk. You're not updating like a single leaf block and then all of its indirects and then doing lots of random writes scattered across the disk like that. The goal of the dedup log is to sort of aggregate a bunch of writes together to give you better performance. And so the changes that I'm working on right now, there's two changes. One of them is a relatively small change to condense the dedup log syncing into a single sync pass. Right now, we like write out part of it in the first sync pass and then part of it in the next sync pass, and we do that for the next few sync passes during a TXG sync. But that sort of undoes a bunch of the benefits that you get by aggregating all these writes together. And so the change is just to do that all in a single sync pass, which reduces the indirect block overhead significantly. That change is relatively small and I think doesn't have that much interesting to talk about, though if people want to talk about it more, we certainly can. The other part of the change is more interesting, and it involves sort of how we decide how many things to flush in a given transaction group. In the current version, the way that it works is that we try to always flush as much as the current sort of ingest rate, like however many entries are being added to the dedup log. And then there's also like a minimum value that we try to do. So it's like, if the ingest rate is really low, we'll still process some minimum value in order to always be making progress on the log to try to get it as small as possible. And that's advantageous because larger logs can increase import times significantly. They have to get pretty big for it to make a noticeable impact, but I mean, you can have a backlog of 1 million entries or something, and it will take a while to import the pool if you have slow disks and have a log that long. And so I was talking to Alexander about this, and he brought up an idea to use a different algorithm. So we were playing around with ideas to like incorporate sort of how big this backlog is when deciding how much data to flush, so that way, if there is a really big backlog, we try to flush more rapidly to sort of bring the size down a little bit. And Alexander brought up the idea of doing, rather than sort of like just try to match the ingest rate directly and trying to, and having like a, a high minimum that sort of stops it from going too slowly. Instead, base the flush rate purely on the size of the backlog, and then like one or two simple tuning parameters. And so the idea is that like every TXG you would flush 1% of the 1% of the current size of the backlog. And so then over time, what that would average out to is you would eventually have, on average, a backlog that is 100 times the ingest rate. And so one nice property of this is that it's very simple. There's only really like one or two parameters to set that sort of, it like naturally matches the ingest rate. We don't have to worry about like whether our moving averages are doing the right thing. There are trade-offs, which is that for some people they prefer sort of very simple, easy to understand metrics, like do this many things per TXG. And this doesn't have that property. Another one is that if the ingest rate drops low, then the backlog, you start flushing at a reasonably high rate, but then slow down as the backlog size shrinks, and it will never go all the way to zero, which is not a problem for like normal steady state operation. Having a little bit of a backlog is fine. But if you are like trying, when your pool gets exported, we try to flush, I believe, the entire backlog. Whenever we kick off a scrub, we try to flush the entire backlog. And if the system crashes and you try to bring it back up, then you need to read in the whole log. And so this gets back to the question of like, will this result in longer import times for users who care about that? And so the thing that I am currently thinking about is basically based on this approach, where it's mostly just the backlog size, divided by this value. But there would still be like the minimum, like a low minimum, just to make sure that the backlog is always being processed at least a little bit, and doesn't have this sort of long tail behavior. And then there would also be a tunable, which would be intended for users who really care about import times, where they could set sort of like a cap on the size of the backlog to try to always make sure that the backlog is smaller than that, so that when they need to do their high availability import in under 2 seconds, they have some confidence that the backlog is going to stay at a size that they are comfortable with. And so I just wanted to sort of discuss the concept with people, see if people had suggestions or feedback on it. If people thought of other sort of negatives or positives of the design that I hadn't previously considered, I'd be happy to hear them. So yeah, I just wanted to sort of take people's temperature on it.
Yeah, that that sounds good. It's a lot simpler than what's in there. I the I don't even know if I have a question. I I did not ever like that stuff was so complicated, but I didn't. Yeah, it kind of grew that way. So it's actually good that you're coming in with a bit of a fresh look. I think the main thing that it wanted to do, whether it succeeded or not, was just to not it sort of viewed the sort of the transaction sync as being we have this limited amount of space or time that we have to put all that we can't blow out, and we don't want to dominate what we're doing. We don't want to dominate like user activity or whatever. So a lot of it was trying to scale back against that or not. Whether it did that or not was a separate thing. Is that still the is that still a sort of a direct goal, or is it more I don't know,
Yeah,
a
I mean,
side
I think
effect of
that,
how this falls out, or if it was never really a problem? I don't know. I don't know what I'm
yeah, I
asking.
mean,
Go. Sorry.
Yeah, no, it's a good question. Because a lot of the logic in there right now is sort of about this, like, don't go past these like time limits that we've imposed. So that way we don't accidentally, have these really long TXGs that present to the user as a stall. We definitely still want some mechanism like that where there's some sort of timing check. This ties a little bit into the next thing that I'm going to talk about, which is that there are 3 or 4 things in ZFS that have a timing mechanism like this, and they don't know about each other. And so they don't like, they're all like, we don't want to take up too much time in case anybody else is working. But also, if all of them are working, we definitely do take up too much time, just like if you add up all the different time-based tasks. And so the next thing I'm going to talk about is sort of like a way for these different tasks to sort of schedule better and communicate together. But I do think we still want to have some mechanism for like, if it's been 2 seconds, you should probably stop. Like the TXG needs to be able to keep moving, even if we haven't flushed quite as much as we would hope to.
Yeah, hard upper limits are always great.
Mhm.
Yeah, no, that all sounds great to me. Good stuff.
Yeah, just like to add that we have somewhat similar mechanism in MetaSlab logs right now, where I'm trying to keep log depths limited to 1000 TXGs, which makes sure that from one side we have reasonable log efficiency, so we're not trying to flush too fast that obsoletes the whole idea of log. On other side, 1000 TXGs usually don't take long enough to import during pull import. I was just dropping ideas to think about whether we could try to tune that value based on size of DDT and so on, so that if DDT is small and we don't need so many blocks, maybe delaying by 1000 TXG is not really needed, or 100 TXG is not needed. But if DDT grows bigger, then to get proper aggregation, we could potentially divide by more chunks by longer TXG as kind of trade-off. Okay, if you have huge pool and huge DDT, maybe you could accept longer import time. But that was just no level of ideas. If somebody would like to comment on that, I haven't developed those too much, too deep. But as Paul described, idea of just flushing certain percent of backlog and limiting minimal amount, that I think should be very good and minimalistic start. 1% of DDT at a time should, I think, give us not as bad aggregation rate as we would go through all the DDT as without any log. So log should be still efficient, and hopefully 100 TXG should not be too long to import. But that's just a guess. Maybe some thinking could be put into there. Minimal amount, I think, should be big enough to handle, to make sure that we are not going to infinite if we start to flush 10, but to flush 10 we need to write X amount of blocks, indirect blocks, and everything else, that with 9, 8, 7, and each time we flush in more and more overhead of blocks, indirect blocks, and transaction commits, and system is idle for last half an hour, but it's still flushing one log entry at a time. That would be a burning of media and it's not needed.
Yeah.
On the other side, I'm thinking that some time accounting may be useful, not from perspective of already warmed up pool where it's not needed, but I worry about pool import time where we don't have DD in RAM, and practically to flush a lot of entries, we need to load a lot of buffer, a lot of ZAP leaves from disk that may significantly increase time we need to flush them. Just synchronous reads are much more expensive than asynchronous writes. And unless we prefetch them and do some other magic, that may create significant difference in flush time.
Yeah. Yeah, I mean, I think that having a sort of a time-based limit helps accommodate that, as you've described. it also helps deal with cases where like, we have like the user has called like ZFS snapshot, and so they're waiting for the next few TSGs to sync out. And so like even if we're not doing as much work as we normally would, it would be good to have some sort of separate limiter in those cases. Which you can just check on like TXG wait synced and stuff like that to sort of see whether someone's waiting. So I think having a time-based mechanism will help with both of those things. The limits can be set relatively conservatively, and even if we don't hit them in normal uses, because as you pointed out, once the cache is once the arc is warmed up, the DDT indirect blocks are all going to be in memory. But until then, it might be useful to have that that time-based limit.
No, I would not like to prioritize applications too much. Otherwise, those log may grow indefinitely and never converge, or at least within a reasonable time. But yeah, having some safety limits, if it's like 5 or 10 seconds, then
yeah, the goal would be that you don't blow out a TXG, basically.
Yeah. Speaking about pull wide background activity, I think right now, aside of DDT sync, we also have we have BRT sync, we have scrub. Do we have other ground activities?
The ones that are sort of time-based are, or that have like time components to them are DDT, scrub and resilver, and error scrub. And async destroy is also under the scrub logic for, I think, historical reasons. Like it's folded into the scrub code a little bit. And then yeah, BRT also has some of this like background sync activity.
But it always flashes. It doesn't have a log, so it doesn't care about time, but it may consume time, unfortunately.
Yeah. So it sounds like people sort of feel comfortable with this proposed design, which is good, and I'm happy to go keep plugging away at that. But that sort of brings us to the next thing that I was going to talk about, which is this idea of sort of a better scheduling system for these background tasks. Because as we discussed right now, there are these different tasks that all sort of want to take up some portion of the idle time on the system to do their various jobs, but they don't coordinate with each other in any way. And so my approach that I was taking is just that there's sort of a two-pass process. In the first step, each of these tasks sort of estimates how much work they have to do, like how much time they would like to spend on their various jobs. And then we just like do some basic math. It's like how much time is left in the TXG, divide that up among the different tasks basically evenly, and then sort of execute each of those tasks with a time limit provided by that scheduler. So they might still have some like floors and ceilings that are controlled by various factors, but they have this time that's sort of the amount that they're trying to hit, with the knowledge that that way, we don't blow out the TXG when we have several different tasks running. And if we only have one task running, we can spend longer on the tasks that we care about. So I just wanted to sort of bring that idea up and see if people had feedback on it or suggestions, thought it was important or not important.
I just wonder, how do you expect them to guess time required? Because for scrub, it's more like work is measured in megabytes or IOs or whatever. For DDT is measured in different entries. It's for everything is different. I'm not sure how will you be able to convert that into time, unless maybe just you can in next TXG take some statistics from the previous ones or somehow else.
Yeah.
Yes.
So right now we do in the DDT, for example, we have sort of ingest rate statistics and like flush time and flush amount statistics. And so you can use that to get an average sort of flush rate, like how long it took to, flush n entries. And then just like multiply that out by the amount that you're trying to flush this TXG to approximate the amount of time you expect to use. In the scrub code, I think we have some statistics for like how much scrubbing is happening. I don't know if it goes down to the TXG level, but it wouldn't be that hard to track. And then we could do a similar thing where we say like, okay, in the last TXG, we scrubbed, this many megabytes in this many seconds. If we're trying like scrub doesn't have sort of a desired rate in the same way that we have in the DDT. But scrubs are also a little interesting from a timing perspective because right now, if you're doing a scrub or a resilver, we actually don't use the normal TXG timeout mechanism. We let the scrub control when the TXG ends. And it sort of like runs a little time-based thing. Like it has its own time-based check that it uses to allow the TXG to progress. So there's some interesting stuff going on with timing there that we need to figure out sort of how we wanted that to behave in this new setup.
Actually, thinking about scrub, that reminds me that it has two separate processes. One is prefetch, one is actual scrub. And since prefetch usually runs faster than scrub, I think since it doesn't know in advance how much will it do, I have feeling that prefetch may regularly overdo things, prefetching the same things again and again. With scrub,
it already does do that, I think. Like in the current implementation of scrub, it all like the checks between the prefetch code and the regular code, I think, are the same, and so it will just prefetch more than it's actually going to use in a given TXG.
Yes, that's what I'm talking about. Just right now, it prefetches quite often more than it needs, but then it next TXG and prefetches it again and again. And would it know in advance how much do we want to do in this TXG? Maybe it could be more reasonable if we know that we will stop at X point.
Yeah. Yeah, if we have better estimates of how much work we're planning to do, then we can not waste as much time doing prefetches we don't care about yet.
But yeah, I think the idea feels right. And I remember thinking a number of times that that was something I really wanted. Like it would be nice just to say to something, hey, I have this much work to do. And it says, cool, you can do this much. And, at an abstract level, it's really nice. And probably just worth building. Yeah, like kind of, I think you mentioned you were sort of going to start with, just the simple version. But I mean, it's like I don't know. I genuinely don't know if it's possible to come up, eventually, once we have some experience with it all, to come up with an idea of, like, here is a discrete unit of, here is a shared idea of what one unit of work is. And it's a similar kind of problem in operating system like task scheduling. If a program has to report on, here's how much I think I'm going to use, but it doesn't know all the other moving parts under that. Like I can say I've got this much stuff that I need to write into a zap, but I don't know anything about the sort of the knock-on effects of that, like the inflation of that, the indirect cost, how it's going to be spread across that sort of thing. So it ends up becoming, you end up needing the tasks have to know a lot more to be able to inform the scheduler, or the scheduler needs to know a lot more about all the different kinds of things to be able to make good choices. And maybe it's I'm not saying we can't do anything or we should not try, but I would be a bit worried about just, is there a point at which we can't go any further because the different things are too different? But and is that point before the point where this is generally useful, if that makes sense? Like, are we just going to try and build a thing and eventually it's going to be like, oh, we can't take this any further and it's not very good as it is right now? Does that make sense? I feel like
It does. Yeah. Your point is a simple solution good enough to give us any benefits, or is a solution simple enough to implement, good enough to give us any benefits?
Something like that.
Yeah. Yeah, I mean, I think that's a reasonable question. I feel like there's a relatively low floor for getting at least a small benefit out of it, where like right now, these different tasks are like, I don't want to take up too much time in case there's other stuff going on, but they don't know if other stuff is going on. And so even just sort of saying like, how many tasks are there, and like, are more than one of them running? Sort of getting this sort of very basic information will at least let us make
Yeah.
some decisions that will make our the sort of life better when you are dealing with these background tasks and care about their performance.
Yeah. And I mean, yeah, and you can get a long way. Like if you find out, well, there's this one thing that always, when it runs, it overwhelms everything else. It's like, well, maybe that just needs, we need to multiply its work estimate by 3, and that always makes it nice. And it's jank, but that stuff often works. So maybe that's the way it gets refined. If I can go for it. It's something we're going to need more. The more we try and do more async work, the more we try and push stuff into the background, the more we're going to need something that has visibility on what everything is doing.
Right.
Because we're just going to waste too much time, and as computers get faster, we have less time to waste. So so yeah.
Yeah. Any other thoughts on this one? All right, and then the last one was a small one. I posted a PR for expanding the sort of table that we use to calculate the fragmentation of a metaslab. Right now it caps out at 16 megabytes, which felt like a lot back in the day when you could have 128 kilobyte allocations and that was it, you're done. But now that 16 megabytes is the maximum for a record size, that doesn't feel like a very useful metaslab anymore. It can satisfy 1 or maybe 0 allocations if you're doing RAISY-3 as well. So just expanding that table upwards to a higher limit to give sort of more nuanced information about metaslabs that aren't yet in that bad of a state, and sort of give more fine-grained information about like if everything is 64 or 128, those are meaningful differences now, but they won't be reflected in the fragmentation unless we increase the table size. So just a relatively small change, and I wanted to sort of see if people had thoughts on it and bring it up and ask people to take a look at it. I know Alexander already took a look at it, but if anybody else wants to.
I agree that there is a problem. I am just trying to argue what is the proper point of 0 fragmentation. Paul's original proposal was 1 gigabyte, but considering that we have metaslabs of potentially 12 megabytes on a small PDFs, I am arguing that value of 128 or maybe 256 megs should be more than enough as non-fragmented. Since it would not give us too much pain unless we feel the pool close to about like 90%, which is not our typical workplace.
Yeah, I think one issue with that is that if you have like 128 megabytes, that's 5 of the max sized allocations. Like if you're doing, RAID Z3 on 16 meg record sizes, the allocations are about 22 megabytes. And so you could fit 5 of those into a metaslab with a 128 megabyte chunk, which is like, that's not that many allocations. There's a meaningful difference between one with a 128 megabyte chunk and one with a 256 megabyte chunk.
But again, it's 80% of pool, 80 something percent, 82, I forgot exact number. It's about 80, I think it's 82% of capacity. Do we care about that high? But if I agree with, if not 128, we can do it to 56. At least freshly created pool of small VDEVs would still get 0 fragmentation.
So it actually will still get 0 fragmentation even with 1 gigabyte, because metaslabs that have never been touched have a fragmentation of 0, no matter what size they are.
They are written single byte and they immediately get fragmentation.
Yes. By default, we don't write to we try to not dirty metaslabs reasonably aggressively. So the pool sort of fills up in order roughly. So I did some tests with even relatively small VDEVs, and you didn't see fragmentation start to rise until you'd filled up a non-trivial chunk of the pool. I also don't know how many users have disks or that are like less than, I don't remember what the number is. Like, is it 100 gigabytes for a 512 megabyte Metaslab?
Yeah, something like that.
Yeah, I don't know how many users have, like, I don't know what sort of disk deployment sizes really look like, but I feel like 100 gigabyte disks are not that big these days. Like most users are using bigger ones.
For ZILs, they are quite possible and
Mm,
likely
that's-
if they over provision it.
Yeah, ZIL disks are definitely smaller. But at the same time, the fragmentation metric is also, somewhat advisory. It's only used in ZFS inside of ZFS itself if you're using the space-based Metaslab weighting, which is not on by default. And it's used by one tunable, which I don't know if it should be used by that tunable, but it is. But that one's easy enough to sort of adjust to whatever to adjust along with the fragmentation table, which I did in the PR's draft. So yeah, I mean, I could certainly see an argument for a smaller size than 1 gigabyte. I sort of just bumped it up to mirror the original, where like they were doing 128 kilobytes, and so they capped the table at 16 megabytes, and I was trying to get it like a similar ratio. But I can knock it down to 512 or 256 to sort of make smaller pools look happier for longer.
Sounds good to me.
Any other comments or?
I think that's everything I had. So if nobody else has anything about those points, then I'm good.
Sounds like you're good. Paul, thank you very much. I appreciate it,
Sure thing.
going through them. And next on the agenda, Alan, I discussed some other topics, some other PRs that have been put up. The next one to discuss is the add native NFS v4 style ZFS ACL support for Linux. This is 16967 PR. And the motivation behind this, oh, go ahead. Yeah.
That's from our side, from IX systems. We're using it for on our NAS systems for quite a while. Originally on Solaris, Illumas, and FreeBSD, ZFS always supported NFS style attribute ACLs that and the same practically format ACL is used by network, obviously by NFS protocol, but also very close format used by SMB, by Microsoft. That's why we use obviously NFS on FreeBSD and Illumas directly supported them on in Samba. We also support ACLs. We map Windows ACLs into NFS v4 style ACLs, and ZFS properly can manage access control the way Windows likes it. The problem appears with Linux, since it supports only POSIX ACL in kernel. You cannot expose ACLs to kernel. You cannot manage ACLs on Linux side. That's why we on Linux implement POSIX ACLs, but those are useless when we talk about NFS or SMB sharing. You cannot map Windows ACLs or NFS ACLs into POSIX. They don't map directly. That's why we decided to expose existing ACLs, NFS ACLs that present inside ZFS outside through the extended attributes interface. That's way applications that know what they're doing, like Samba, can read and write ACLs directly in a way they are handled by both sides, by both ZFS and Windows on the other side. So this sets adds the respective extended attribute support, plus it also introduces user space library to manage them, plus Python wrappers to actually use them easily, and simple utilities and tests to do that. As I've told, we are using those interfaces for quite a while and are happy about it. And actually, it's a third attempt to upstream it. Previous couple died with a lack of reviews, so we would like to bring more attention to it. I just completed one more pass, especially through kernel code, But if somebody wants to review user space and Python parts, maybe somebody wish some or have some wishes and proposals to improve it. So it's welcome. But I think many people would like it to actually land. Ideally, would be have Linux kernel supported, but that's who knows if it ever happens. And aside of that, this is the closest thing we can do probably.
Yeah, I think this makes a lot of sense, actually. It's been on the wish list for people for a very long time. And like you said, there have been a couple previous attempts at it. Did you look at any of the other implementations out there for like the tooling, like Rich Ackles, or I know that I haven't looked at it in a long time, if that moved forward, like in the kernel community? Because I know there were other attempts to get non-POSIX Ackles into the kernel, but I don't know if they stalled out or what.
I know nothing about kernel side changes. We implemented this one and they've told we're using it for years.
Okay.
So
It might be worth looking around a little bit because there may be other existing tools or standards out there for manipulating NFS style ACLs on Linux. It'd be nice to make.
Is there something that landed? Do you mean something landed already upstream, or is permanent floating around patches?
Permanent floating around patches, probably, right? There's a proposal for well, there have been a bunch of proposals for like this that never went anywhere on Linux, is my recollection, right? I don't know. I'm just curious what their current state was. You know, if they were
No,
actually
I don't think this
considered or dead, you know.
I don't think this creates any problem with maintenance, or if there appear other interfaces, they could be implemented in parallel potentially, but
Yeah,
in a lack of any.
The only concern I have there is I think they expose these through ACLs too, through the trusted, not ACLs, through the extended adders interface. And it would be good to make sure that we pick different names with anything else that might be out there. So make sure we don't conflict, just in case. Or if we do conflict, we conflict in a compatible way.
No, the binary format here just follows NFS attributes, so I think we are as close to potentially be compatible as we can, but yeah, I don't know anything about alternatives.
Okay, well, I'm happy to take a look at this. So at least the user space bits and the kernel space bits.
That's great.
Please.
Any other comments from the team? All right. We'll move on to the next one, PR 16929. Optimize receive fix encryption hierarchy. Any thoughts on this one, or? They're talking about going through the file systems and for each traversing the snapshots. So there's comments about that causes issues where you were pegging the CPU on this one. I don't know if people have seen this or run into this. Any thoughts?
Yeah, I saw it, and I saw that it's in user space in libzfs and science. I wasn't very familiar with the area. I haven't looked deep, but if somebody else was there deeper, would be nice. But I haven't personally reviewed it.
Yeah, I made a first pass over this one, and it looked pretty reasonable to me. So I think I posted a few comments, but I haven't circled back on it yet. But I can give it another look.
The problem is that everything involving
Great.
send-R and send-I scares me.
Yeah, that's yeah. Just scare everybody.
All right. Any other comments before we move on to the next one? All right. The next one we have is PR 16913. This is the one that allows zpool status-c to also specify vdev properties. Looks like they want to overload with the -c, include vdev properties in the zpool status output, overloading that zpool status-c. Is that an issue to overload it?
I think we've discussed it last time.
Oh, okay.
Yeah.
It feels familiar. It's at least the link at its issue, not PR. But yeah, I think it would. I think we agreed that it would be a nice feature. We had just question of what to do with potentially properties of pool level properties. Like top level differentiation between the pool properties and top level VDEF property. They have exactly the same name, but potentially conflicting what to show. I think there one attribute that was conflicting. I forgot which one was that. I think one was found. But once we formalize that question, I think it would be a nice feature be able to see that.
Okay, so basically there'd have to be some renaming. There's duplicate names if you overload it, type thing.
Or just understanding what do we show in each specific case. Renaming of property is probably not realistic and not needed for this minor feature. But proper understanding what do we exactly show in that case and how do we show all the levels, and as I've told primarily top level PDF.
Okay. Any other comments? All right, go to the next one. And the last PR that we had. Oh, did I miss something?
No, the last one.
Okay, go for it. Yeah,
the last one.
16991.
Yeah, it's not mine, but I added it just to bring attention to it. I have feeling in some cases, or maybe on Dev Summit, we discussed that our permission system sometimes lack for better, and in a terms of specificity of certain permissions. In some cases, we'd like to have them more fine-grained to be able to not give too much permission. And here, somebody reported case when ZFS receive minus capital F can actually delete snapshots without permission given to delete snapshots. And I find it difficult to fix since it breaks compatibility with potentially a lot of software. I don't have exactly ideas how to handle transition. That's where I'd like to bring attention, and in case somebody has good idea, so at least make people think about ideas and maybe comment there later. But my thinking there was, while we are doing that, would be nice to split that minus capital F feature into several other ones. For example, when we are the most obvious case of rollback during receive is then we want to drop local changes but keep the last available snapshot, but don't delete snapshots. That's quite useful situation in many backup scenarios when you don't care about local changes, which are likely just a time modification, and you be happily drop them. But you definitely don't want that your system potentially being hacked and trying to upload some garbage or delete. You don't want it to be able to delete earlier uploads, earlier backups. And it would be nice, I think, to have separate feature less aggressive than that minus capital F, that to revert only latest changes. As next step could be another flag to revert, maybe delete some last snapshots, but not other ones, because in user space, that minus capital F, it may also delete all snapshots if it's a replication stream. It may even handle some renames. So it's a very busy flag doing everything at once. But at least for deletes old and renames, it uses separate permissions, requires separate permissions. But when we're talking about deleting last snapshots, there it just doing it without any permissions. So if somebody has ideas, what shall we do about this mess, would be good to hear. And actually the same differentiation could be added to the revert rollback command, which right now either can roll back everything or roll back nothing. Maybe we could also make it more fine granular. Science is practically the same operation.
So I do have some ideas, but I don't have a lot of info in front of me, so I'll do this. So there's a few different bits there. One, the easier one I think is with the just forcing flags in general. A while ago, I had a PR. I can't see it in front of me quickly. I had a PR about not letting the user do weird weird pull layouts that are going to be like these will work, but probably aren't the thing you want, like a a 2 device Z1, for example. And that stalled because we sort of wanted to have a more general mechanism for providing force to be able to say like dash dash force dash thing, rather than having everything under a dash F flag. So that's sort of that I think we can do really easily. It's mostly just a code read, which I've started doing, and then breaking out different kinds of, we're forcing VDEBs or we're forcing this, and have a common sort of language for that. So that's that side of it. And then we don't need to think about that again. Permissions, there are, and I need to dig some up because I don't remember this very well, but there are like access control kind of data models that exist. It's sort of in research papers and stuff that people have done sort of the modeling. Here is a reasonable way to express fine-grained permissions and then like groups of permissions that activate or deactivate other ones, and then concepts of things like users and groups and how to apply that. So there are sort of standard models that are good in a lot of cases, which it might be I will go and see what I can find, because it might be worth having something like that. Build that, and then we can sort of remodel our existing access controls in terms of like new ones. We keep the old ones around as a legacy thing, which can be turned off down the track. But then we have things that can say, to do this particular operation or this particular version of this operation, you need these 7 flags. Then some things are policy, like, this user should be able to delete. I don't know if there was a request for this, but this user should be able to delete old snapshots, but not the most recent snapshot or something like that. I don't really know how you express that because it's not really an access model. It's more of a site policy. We don't want to hard code that, but we have talked about, there are places where we would like to be able to present policy decisions, inside pull config. An example is that isn't quite related is VDEV slow IO configuration for Z. That's very much, we have these special policy parameters that we don't actually care about, but they're just there to allow the administrator to wire up all these pieces of software. So possibly we may need a more generalized policy mechanism. I don't know what that means exactly. And then the last bit is auditing. One of the things that I only know it from Linux, from like AuditD and like AppArmor and this sort of thing. There are things you can there's like modes you can run things in where you can say, if you hit a policy check or if you hit an access control check and I don't have access for it, log something but still let it through, and then I can take that information later and use that to build up my access tables. But at some point we're going to need to do like an audit of all these code paths to find out, this thing does actually then jump over here and does some unrelated option, like we snapshot a thing and it destroys something. Does that need that access control or not? So you end up having access control checks in interesting places. So there's a bunch of different pieces. There's a bunch of different ways we could go. None of that is a specific thing, but the call was for ideas, so I'm getting away from it. But there's lots of scope to move if someone is interested in getting started, and I hear people ask for more access control stuff all the time. So just having an existing model to shove that into would be great, rather than having to think too much about, well, what do we what are we accidentally enabling when we modify something? Yeah, that would be really good.
Oh yeah, but one thing that remains and that worries more is shall we keep minus F capital with receive permission be able to deleting things, or we actually should forbid it and break everybody doing replication in the world?
On that one, I mean, we can do whatever we want. On the, and I mean, that speaks to some kind of deprecation policy, and do we have that, and how? And I was thinking about that with like ZPL's status and the -C stuff. Like, how set in stone do we consider some of our like interface pieces? Yeah, maybe I'd make the argument that force flags, all bets are off. Like, as long as we give you a way to do the thing that you are already doing, then I don't mind changing a force flag. But I don't know. Is there a
Problem
yeah, do we have a
with replication is
deprecation
that
policy for this?
if you're using push replication, practically a receive command is hard coded on the sender side. So just updating the receiving system, you're breaking all your senders immediately. So the only nicest thing I can think about is that we implement additional mechanism and consider that, yeah, minus F capital is unsafe. And then we would need to introduce additional permission receive better.
Yeah.
That people should be encouraged to use instead of receive, and give it few years, and then start scraping old receive or F or something like that.
Yeah. And I mean, yeah, we have a lot of things like that. I think we've got so much stuff that's been baked in for so long, and we're now running into the edges of some of it, and we want to change it. So, I don't know how to. I don't know if I can just decide. So, there's a lot of things where I have a reasonable gut feel about things, but I have no idea. But you know, we probably need to just do it. And yeah, and if we just want to have a long sort of deprecation policy, we, you know, if we remove it, you know, we give you a way to do the thing you want to do, but we'll keep the old one alive for like 2 major releases or something, and it's explicitly marked deprecated in the docs or whatever, and we just telegraph it as widely as we can in you know, our release documentation and whatever else. Like, it all sucks, but we can just steal someone else's idea. Like, lots of projects and lots of languages and lots of stuff do this. I think we just got to decide to do one though, to as a project to do something, and I'm not sure how we make those kind of decisions. Are they just someone just rule on it, or do we just do it? I tend to just do things and wait for people to say no. But I don't know, Brian, you're here. What do we do?
So in the past, what we've done is, you know, we've kept things around for quite a long time. We've marked them as deprecated and then kept them around for a major release or two, just because we don't want to break people's stuff, right? We don't know exactly how people are using the tools and whatnot, and or how big a lift it is necessarily for them to update and move forward. So I think it's okay if we have, you know, a new way to do a thing, as long as we keep the old way around for a little while, as long as it isn't really expensive to maintain or really difficult to maintain on our part. So it's kind of a trade-off there, right? We actually don't have a really long track record of deprecating things in ZFS. They kind of stick around forever, right? As long as we can. So yeah, I hear you on having a better policy for that. But like I say, I where we've come down to this in the past, or where I've come down to this in the past, is like try not to break people's stuff, right? And then give them plenty of warning if you're about to do it. So I guess I'd be in favor of that kind of approach.
I agree with that. I'm not in any hurry.
Definitely makes sense, because it's not fun when you're broken on the other end. You know?
Yeah, we've all been there, right?
Yeah, yeah. At
Agreed.
least a
But
couple
back
of
to the
releases. Yeah.
so
Oh, go ahead.
but with the access control things itself, I'll make a note and I'll see if I can, because I referenced a few things. I'll see if I can dig up some notes and papers and stuff. It's all previous life stuff, so it's at least 5-6 years old. So I need to swap that back in. But I'll see if I can find and add some stuff to the ticket because it'd probably be useful to have some resources that we can start thinking about. If that's all right.
That sounds great. Thanks, Rob.
Okay.
Anything else we want to talk about? That's it for the agenda items. And just to mention, the next meeting is going to be 4 weeks from now. So it's February 25th, but it's going to be earlier. So it'll actually be 3 hours earlier in the day for people. So 1 p.m. Eastern time zone, and then translated to everybody else's time zone. But just kind of a heads up for next time. And that's it. And Alan will be back, your favorite host. So you'll have him back in a month. So everybody have a great rest of your week, okay? Thank you.
Yeah. Thanks, everybody.
Thanks, everyone. Thanks, Cynthia. Bye.
Thanks. Bye-bye.